All right, guys, I've got a little piece of stainless on the table here. I wanted to kind of go through, maybe what it looks like to actually start the machine up, load parts in, whatever. So right here, we're gonna add some parts. I need one of those, one of those. I actually need two of these, and then I need two of these as well. So on here, we've got the stars, what's the most critical. So say you're cutting out a bunch of parts out of a sheet, and say maybe you have a production line going and you need a certain part first before you need the other part or whatever. There's multiple different reasons why, a part would be more critical than the other. Say you have a small sheet and you're just cutting out some trinkets or something like that, and you're like, hey, not a huge deal. I don't need all of these, but I would like to have these before this. That's where these stars would come in, the favorites would come in. On this, I know my sheet's big enough to nest everything, so it's not a big deal. All right, so coming in here into the nest, this is the parts interval. How much space do you want left in between your parts? We find a 1/16 is pretty good for most everything we use. Come down here to standard plates. So our length of the plate, which is your y-axis, and the width of the plate is 28. So go ahead, hit it. It goes ahead and nests all of our parts in. As you can see up here, all of our parts fit into this size sheet. So we can see our little bit of room there. We don't need to on this one, but just for talking points, we can go under favorites and say, like this little part right here, say we didn't want it to fall out. We can put something in there that they call micro joint, and we can pick whether we want it to add to a lead line or add the lead line to the micro joint, where it starts off of it and then comes in, say it'll start over here and then come into the part. We don't necessarily want that. But one of the big things that you would use, say you were doing 480 caps for handrails or feet or whatever, you would want it to apply to the same graphic. So say we go over here. Let's say that this part is small enough and we think it's going to be somewhere on the plate that it might fall out and cause a collision later on. We would go ahead and put in a micro joint, and you can tell it puts in a little line. So what that machine's going to do is it's going to start here. It's going to go ahead and cut all the way over, and then it's going to pick up. It's going to go back down, go through its pierce settings, and then it'll go back on the other side of that, and it will leave a, whatever I had that set to, 0.05 micro joint. So just under a 1/16. It's small enough where you can still break it off. It doesn't hinder the part very much. Like on this specific part, we don't actually need them, but say you had somewhere that was going to be welded, say out here was all going to be, a finished product. You didn't want to compromise this cut quality here. You might want to come in and put it here somewhere. The part's still not going to fall out. We are actually going to weld this specific area. So it's not a big hindrance if it's got a little bitty tit left on it. We could either hit it with a buffing wheel if we wanted to or whatever. Typically, it's not going to screw us if we were to do that. Again, we don't need that on this, so I'm going to go ahead and pull those out. But just wanted to show you how to get parts in and nest them. So now that we have all of our parts in here, it's nested on this sheet. What we will do first is go ahead. I always run my Z-axis down within a couple inches just because I'm impatient and the calibration takes a little bit of time. So on our remote, we can press cap calibrate, or we can go up here to CNC and we can do calibrate, and it will go ahead and calibrate the laser to this new nozzle, the different nozzle rather than what it was previously using. It'll go ahead and go down. It doesn't touch the plate, but it knows now where the height of the plate is for whenever it goes to run out its file. And it'll go ahead, the Z-axis will come up to 0. All right, everything's good and stable. So we'll exit out of that. As you've seen there, our alarm went away. So the next thing would be edge detect. So if you've been using it for quite a while, or say your parts are real small, it doesn't matter, what this edge that it goes off of and this edge, it's not a big deal. You can move it over to the center of the sheet. I like to try to utilize all my stuff. So we're gonna do an edge detect. The plate, whenever you put it on there, you might have it skewed just a little bit. I like the 3-point edge detect myself. It does a really good job of tracking that y-axis on the left side. So our x-axis on this specific sheet is 28, and then our y-axis on this one is 17.25. So what we'll do is press start edge detect. It will run the head down and it will go over and find all the edges. We've given it an edge off of distance, or edge distance rather. So it is 1/8 of an inch off of the y-axis and 1/8 of an inch off of the x-axis here. Big thing here, because I've screwed it up in the past. So obviously you see now that this angle is a little bit different. That's just showing how the plate is skewed on the table. We will save that so that we don't lose that. And then the next thing that's very critical here is the frame. So we want to make sure that our parts are actually going to fit within the sheet. So I'm going to go ahead, press frame, and you can watch the laser go by, and okay, yes, everything's going to fit on our sheet very well. I don't know if you had seen there on the bottom right hand of the x-axis, looked like it might have been running off just a fuzz. So what I'm going to do is I'm going to press step on my remote, and I'm going to go ahead and run it up a couple and then over a couple. So the step is whatever we set this measurement to down here. So if you hold step and then jog on your remote, it only moves that 1/16 of an inch that we have it set. One of the things that I do want to point out that I didn't talk about while we were cutting the carbon there, you know, you can see the laser really well right now on that nice bright stainless, or I hope you can with the DJI. You may have to go ahead and run that laser on down if you're doing carbon, especially, you know, this is a big old bed. You can't see real well all the way down the machine. That's the only one of the cons that I would say of this setup with the door closed. When the door gets dirty, you can't really see all the way down to the end. Do better maintenance, jackass. I know all this stuff. Clean your door. But nevertheless, if you're running big production runs, that's just something to take into consideration. So we showed you how to get parts in, we showed you how to nest the parts, and we showed you how to edge detect, and we showed you how to frame. So now it's all left to do is let's cut some material. A little bit of a teaser. On the next video, we're gonna actually start getting into the breakdown of what it costs to run this laser day in and day out. Break down that $180 an hour price range just a little bit. Gas consumption, power consumption, all that, so on and so forth. How we come up with our $180 an hour. Don't even really wanna pull the piece out and show you just because the cut quality is rather bad. So you've seen that we had a stop about 3/4 of the way through cutting this one. I didn't have my regulator set high enough. We had a brand new bottle on and the regulator was set down a little bit. Anyway, just had to put 1/4 of a turn in that and it was fine. Over here, you've seen it stop. I set this sheet upside down. You can see the little piece of dross from the cut before because we cut on this sheet, and that cut was over there close enough where it actually detected and hit that and essentially made it like a collision. So anyway, may have seen that little circle cut out on the stainless. We had our settings wrong, so had to switch settings back. Like I said, stainless it's brutal as far as on the nitrogen usage. You seen the gauge going down there. We ended up using 1,500 pounds of nitrogen just on this. Again, not gonna say that my cut parameters are 100%, not gonna say they're great. I got it to where I could get it cut and get this job done and get it out. I personally don't care to mess with much more stainless, but nevertheless, I had to on this deal. It was for a big client of ours and needed to get it done. So anyway, hope you guys got some useful information out of this video. Like, comment, subscribe. If you've got a laser friend, guys work for you in the shop, whatever, share it to them. We sure would appreciate it. Thanks for tagging along. We'll see you guys on the next one.